Alright guys, Miss Sturgeon here again. So for this next part, we are going to be talking about what's called difference of two squares. So for this first example, I'm just gonna kind of like walk you through the steps that we learned in the last video using your A times C, all that good stuff, and then we're gonna see if we can come up with a shortcut for these. Just because when we're factoring and we're trying to, get through problems in the future, this would be a good situation to just kind of be able to see a difference of two squares and factor it right off the bat without necessarily going through all those steps. You can always use the steps that should work if it's factorable, but let's try this. So first things first, you're always going to look for a GCF. So, and remember, the steps I'm referring to are the ones from the last video, right up here. So first thing, I'm going to not scroll back and forth between those the whole video though. So take out a GCF. So I noticed that both 5x squared and negative 125 are divisible by 5. So I'm going to take the 5, write it outside a set of parentheses, and then I would get x squared minus 25 left inside of the parentheses. Again, if I distribute that out, I should get back 5x squared minus 125, and I do. So next, I'm going to focus just on the inside part of the parentheses here. Multiply your A times your C. This gets confusing for some people because they're like, well, there's only two terms, okay? So notice that you don't have a number in front of an x here. There's no like bx term. So basically you're trying to figure out what are two numbers that multiply to get A times C. So A is 1, C is negative 25, so negative 25. Multiply to get negative 25, but add to get 0. If there's no b term, then we can assume b is 0, because it's not there. We don't see it. All right, so two numbers that multiply to get negative 25 but add to get 0 would be negative 5 and 5. Okay, so I'm going to go through the steps. You guys should kind of notice something that happens here. So you get x squared minus 5x plus 5x minus 25. Again, this part replace the middle term that in this case doesn't exist. So negative 5x plus 5x, that would just, if you combine those like terms, you would get 0. So group the two, take out a GCF, you get x parentheses x minus 5. Take out a GCF here, you get 5 parentheses x minus 5. Good news, we found the same set of parentheses in both, so we can take out that as a GCF, so we get x plus 5, x minus 5, and then my GCF is written on the outside still, that 5 from up here, this 5. Okay, I want to point out a bunch of things here. First things first, I would like to point out that you can notice something where I wrote negative 5 and 5 with my x method over here. You might notice in my final answer is just x plus 5, x minus 5, just like the numbers I have here. We have a positive 5 and a negative 5. So you could kind of jump to the final answer for this one, and really any problem where you have your A value as 1, you might start noticing some patterns here and that you might be able to skip some steps and get to the final answer. Okay, that's not by chance. That's actually a good way to be thinking about these problems. So that's the first thing I want to point out. The second thing I want to point out is that notice 25 is a perfect square. We talked about perfect squares a lot when we were solving these equations by taking roots. So like another way that you could have solved this instead of factoring, we just talked about it a couple of days ago. If I were to take 5x squared minus 125, add 125 to both sides, divide by 5, you would get x squared equals 25. Square root both sides, you get x equals plus or minus 5. Well, guess what? If I take each of these factors and set them equal to 0 and solve, so x plus 5 equals 0 and x minus 5 equals 0. If I do that, then I'm going to get x equals positive 5, over here positive 5, and x equals negative 5 for this one. Hey, that's the same answer. Okay, so that's kind of where the difference of two squares comes in. The reason it's called, so I'm going to write this down for us. The reason that this is called a difference of two squares, difference, oh, I spelled that very wrong, difference of two squares. Okay, the word difference is coming from the fact that we're talking about subtraction, right? X squared minus 25, so that's where the difference comes in. And squares is talking about perfect squares. Okay, so I have two numbers that can be that are perfect squares, right? When you square root them, essentially you get a whole number, in this case x squared, you would just get an x. Okay, so just a few patterns I wanted to point out. So basically, when you're factoring a difference of two squares, you can kind of do it a little quicker than that. So you might even be able to look at something like number 13 and just know how to factor it right off the bat and just say it's going to factor to be, if I'm thinking of numbers that multiply to get -9 and add to get 0, I'll get -3 and +3. Okay, so the way that this would factor would just be x minus 3, x plus 3. Without doing all those steps, without dealing with all of that, again, that's a quick and easy way to do it. You would just take each of these factors then equal and set them equal to 0 and solve to figure out where it crosses the x-axis. So x minus 3 equals 0, x plus 3 equals 0. Add 3 to both sides, you get x equals 3. Subtract 3 from both sides, you get x equals -3. Okay, so, and again, you could get that the same way if you just solve to get x by itself in this case, but if the problem tells you just to factor it, then you do need to be able to know how to do that. And we will need to know how to do that for other circumstances, like later on in the year when we talk about rational functions. So you'll see it will come up where you do just have to factor it and not solve it. But knowing these patterns and little tricks and things is going to help do that a little faster, so you don't have to do all those steps. So real quick, this should be fast, number 14. First thing, take out a GCF, so I write a 2 on the outside. We get x squared minus 64 equals 0. I notice this is a difference of two squares because both x squared and -64 are perfect squares. So this can factor to be x plus 8 and x minus 8. So then my answers, if I set each of these equal to 0 and solve it, I would get x equals -8 and x equals +8 final answers. Okay, and I can always check this by taking the original function, typing it into a graphing calculator and see where it crosses the x-axis, but I'm not going to go ahead and show you guys that. You guys can do that on your own time. Last but not least, I would actually like to try number 16, but we're going to pretend instead of a 4 here that it's a 2. Okay. Last thing. So the reason I want to do this one is because the number you see in front is not just x squared, okay, and there's no GCF. So in this case, the way that this would factor, the way that I think about this, and this is where the pattern of difference of two squares comes in, is you end up getting essentially the first space that you're filling out for each of these is kind of like the square root of the number you're dealing with. So if in this case it's 4x squared, the square root of 4 is 2. So that means this would be 2x and this would be 2x. Okay, then in all of my difference of two squares problems, I had a plus sign on one of the parentheses and a minus sign on the other. Okay, that's going to be the same here. We're going to check our answer to make sure that this works. And then again, thinking of the pattern here, your square root of 9 is 3. So that means you have a plus 3 and a minus 3. And let's double check this to see if it actually worked. So I'm going to do distributive property. So 2x times 2x is 4x squared. So this is my check. 4x squared. And then 2x times -3 is -6x. 3 times 2x is +6x. 3 times -3 is -9. -6x plus 6x is 0, so you get a final answer of 4x squared minus 9. That checks out. So you could find the answer by setting each of these equal to 0 and solving. -3 equals 0, so you would solve, subtract the 3, 2x equals -3, x equals -3 over 2. And then add 3 to both sides, so you get 2x equals 3. Divide by 2, you get x equals 3/2. So you get plus or minus 3/2. You would get the same thing if you were to solve this by taking roots. But again, please know how to factor these just in case we need to factor problems like these later on, which we likely will. Okay, that's difference of two squares.